Hello, my name is Renata and welcome to this presentation on number needed to treat, number needed to harm. This is my chosen topic for the second assessment exercise for HEA 201, Integrating Evidence into Practice. So firstly, let's look at the number needed to treat. This is a statistical concept that helps a researcher or a health practitioner to establish the clinical worth of a treatment. Quite simply, it demonstrates how many persons or subjects will need to receive a treatment for a benefit to be gained or harm avoided by one person. I, like many, have been under the misconception that treatments are designed to benefit all who are given them. This is in fact not the case. It may actually mean that 50 people need to undertake a treatment to avoid one bad event, or 200 people, or even 1,000 people. Also to be taken into consideration is the cost, or the potential to cause harm from a treatment. Are there any adverse effects that are shown to occur more frequently than the beneficial effect? How many persons need to be given this treatment for it to cause harm to one person? So how is the number needed to treat calculated? Firstly, the absolute risk reduction must be calculated, and this is calculated as the rate of a specific event occurring in the experimental group minus the rate of that same event occurring in the control group. Then 1 is divided by the absolute risk reduction to give us the number needed to treat. To calculate the number needed to harm, the absolute harm increase is substituted for the absolute risk reduction. An example of this in medicine that I find personally very interesting, and perhaps I'm a little shocked by, is the example of the use of statin drug treatment to prevent heart disease. The statistics speak for themselves. A systematic review of 19 trials showed that statin drugs were not shown to be a life-saving treatment for adults that had not had previous incidents of heart disease. 104 patients was the number needed to treat to prevent one heart attack. The number needed to treat for stroke was even greater, with 154 patients needed to treat to prevent one stroke occurrence. Perhaps the most shocking statistics here are the ones relating to the number needed to harm. The systematic review showed that of every 50 patients taking a statin, 1 will develop diabetes, and 1 in 10 will have some form of muscle damage. So is the treatment worth the cost? Not just from a monetary point of view, rather does the potential for benefit outweigh the potential for harm? In the case of statin drugs, is the potential to be the 1 out of 104 that will avoid a heart attack more important than being the 1 out of 50 that will develop diabetes? While this is only one example of comparing the number needed to treat to the number needed to harm, it is a reminder of the importance of applying this statistical concept to the appraisal of clinical results. Thank you very much for watching this presentation.